Hey everyone, so let's get started with a Python primer. Now, there's a lot of contexts in which you can apply Python in Houdini. We're going to start with the two most basic and commonly used, and then later down the line we're going to access some of the others when we know a little bit more about Python. So the most common or sort of good starting place is the Python shell. In a basic build desktop, it's not on display by default, but I highly recommend having one on display all the time, not collapsed, but actually open, because then any tools will print to this, and then you have a history of any printed errors or things. I'm going to now just expand mine because, of course, we're just going to be doing a lot of Python shell stuff. You can also have a floating window. So there we are, Python shell, and you can have a floating window. Of course, you can make it always on top if you're wanting to do a floating window so it doesn't disappear when you click away. But I recommend having one actually locked into a panel, and then we can work with this. Of course, you can make multiple Python shells as well. And later I'm going to show you lots of cool tricks we can do with the Python shell, dragging things in and all that type of stuff. The Python shell is not a good place for writing long code. It's possible to do it, but it's very cumbersome. You really want to do one-liners or sort of just test things. And that's also a good place that stuff will get printed to from the next context we're going to talk about, which is the Python source editor. So this is only a pop-up window. So a floating window. There is no embedded version of it. So you have to have this floating. So I just recommend saying always on top, depending on your OS. Here you can write lines of code, and then only when you hit apply does it actually run it. I do want you to keep in mind though that this does save with the HIP file, and when you open your HIP file it will execute the code in here, so you need to be careful of what's in here. Typically you don't leave stuff in here. You'll write code in here to test it, then copy that into another context where it's actually going to be applied. So we don't just leave stuff living in here. If you do want to leave it and come back to it later, you can select it all and comment it out so that it doesn't run on the next time you open Houdini. It prints to the Python shell, so it doesn't, it will print warnings down here, but any normal prints will actually go to any Python shell that is open. So that's why I recommend having these two open in tandem. So you can use the Python shell for quick little tests and one-liners, as well as having it be a print for the Python source editor where we're going to do most of our test coding. And then once the code is working here, we copy it into some other context like a shelf tool or an HDA. So to begin, we need to know how to create variables in Python. Variables are used all the time in coding. If you don't know what a variable is, it's basically just a word with a stored value. And in Python, it's incredibly easy to set a variable, even easier than in Vex. So here we can just create a variable, something like myvar, and we can just put an equal sign and then give it a value. So let's say 3. All right, so now we've created a variable. See, in Vex, you would need to typecast, so call this, let's say, a float or an integer in order to create that variable. In Python, you do not need to do that. It automatically detects what type you've given it. It's important to note that though, because if you want this to be a float instead of an integer, then you would have to say 3.0 instead of 3, and it will then figure out that that is a float instead of an integer. Likewise, you could wrap it in a float typecast, and it would force it to be a float. But Python's basically going to guess based on the value you give it what the variable type should be. And it's also very good at changing type. So if you override it later with a different value, it will actually accept that new value and accept that new type, whereas Vex, once it's typecast, will want to remain that type forever and will not accept values fed into it that are not of that type. So Python's very flexible in that way. So this is how we set a variable, and then we can call a variable later by just simply referring to the name, so myvar. So again, we don't have to typecast like in Vex. If you're referring to an attribute or something, go f at or I at or whatever. We just call the name. So we could say, for example, we can use this in our print function. So if we want to see what that value is, we just print, and we, in the brackets, what do we want to print? We want to print myvar. If we click apply, you'll see there it prints 3. Right. This is also a good time to talk about the print function. This is going to be incredibly useful. So it is just simply print and then in brackets what you want to print. It can print variables as well as anything else, like you could feed it numbers and text and whatever, and it'll just print it. You'll see that we're using Houdini 20.5.278, but any of the latest versions of Houdini are going to be using Python 3, so Python 3.11.7 in this particular case. But as long as you're not on Python 2.7 with a very old version of Houdini, then print will work this way. The old way was actually to print like this, so there was a space and no brackets, but now it's a print function like this. Okay, so that's how you print, that's how you create a variable, and that's how you call a variable. Now you'll notice I've been talking about the different attribute types or variable types, like float and int. If you're familiar with Houdini, you should already be familiar with these terms, but I'll do a refresher and also talk about some of the types that exist in Python that do not exist elsewhere in Houdini and in Vex. So integers are round numbers, whole numbers, right? So 3 with no point anything at the end, not even 0.0, just 3, that is an integer, right? And to typecast it for an integer, it's int. You don't have to write the whole word integer, it's just int. Floats, so 3.0 or 3.5 or 3 point whatever is a float, so that allows you to have floating point values. Also, both integers and floats can go into the negative, that's fine, and both can be 0, but a float that is 0 would also be 0.0. Okay, so those are floats, and again, to typecast into float, you would use it's the whole word float. Okay, so those are the two number types. Then we also have booleans. Now in Vex, if you do like a logic statement, true would be 1 and false is 0. But in Python, you actually have a true and false value. You'll see that the color changes, so you can see that it's a special value rather than it just being the word true, like a string. It is a capital T and then true, or capital F for false, and you'll see the color changes there. Okay, and now here we can print, you'll see when I print, it prints false. This is not the same as it being a string with the word false. It will print the same, it sort of looks the same when it prints, but it is not treated the same. This is a string, which is a sort of an array of different characters. When it is actually false like this, other functions will understand how to work with this. It's also important to note that although it is not just 0 and 1, it is false and true, in some contexts, it can be treated like a 0. So for example, if we multiplied by 10, so it's saying print the result of taking this variable multiplied by 10, so false times 10 is going to just equal 0. It treats false like it is 0 in some contexts, or in this case, if I changed it to true, it would print 10 because 10 times 1 is 10. Okay, so in certain contexts, it'll treat it as a 0 or 1, but do be aware that it is not exactly the same. Okay. Then, besides that, we also have another special type, which is none. None is often returned by functions when they don't actually return anything, so they're not meant to return anything, or they failed in some way and then returned nothing, or they're maybe meant to find something and what you asked them to find doesn't exist, then it will return none. So it's essentially saying I have no value, which is not the same as 0. It will not treat it like a 0, so if we say myvar times 10 now, it's going to give us an error because it doesn't know how to work with that and treat it like a 0. It is not a 0, it is none, it is nothing, it has no value. Now you can still use this in logic statements though, in the same way that false would say, so if you put an if myvar was false, then the if statement would not execute. It's the same with if myvar is none, the if statement will not execute. So in some ways it treats it like false, but you can see there it is different to false because it doesn't treat it like a 0 when you multiply. So there are a few differences. Okay, and it's a very useful type because we want to know whether something actually has a value stored or whether nothing is stored in that variable. Okay. Then we have strings, which we've already alluded to before, but a string like that is just some text, okay? It has to be in quotes, either two sets of double quotes or single quotes. It's actually better practice to start with single quotes, and then if you wanted quoted text inside of the text, you would use double quotes like that. So now it would print with those as actual characters, but it is up to you. It will work if you use double quotes, but the most common best practice is to use single quotes there. Okay, so this is a string. It can have numbers in it as well, special characters. Now, certain special characters will actually act like special characters within there. For example, we can, it's this way, we can put a tab, so it's actually tabbing in some space. So you don't want to, you need to be careful. If you see the color change, then it's using a special kind of character. Particularly, it'll be following a slash. Okay, so you do not want to do that unless you know that's exactly the result you're after. But mostly other special characters will happily print as part of that string. Now, strings in a lot of cases are treated like arrays, so that any functions that work with arrays will usually work on strings as well. Not all of them, but quite a lot of them. So you can think of this as an array of characters, of individual, letters and numbers, including white spaces. So you'll see it does keep the white spaces. It treats those as actual characters, and it will print them that same way. You do not have to have underscores. And then, just as we move forward and learn about arrays, just keep in mind a lot of those functions will also work on strings. Okay. Then let's talk about arrays. Now, we're going to get into much more detail about arrays, but just so you know, there are different types of these arrays. And arrays are essentially just a collection of other values. So you can think of it as a compound object. So it stores multiple values in one single object. That you could then break apart and pull those individual values out of. So we have lists, which basically look like this, that can store multiple different values, and you can work with that and change them. You get tuples, which will look like this with round brackets. Don't worry, I'm going to explain these more in their own lesson. But you've got tuples that have round brackets, you have sets that have curly brackets, and then you also have dictionaries where you have some kind of key and value pair. Okay, so these are the different types of arrays in Python, and they're essentially ways of storing more information into one compound object. Okay. Arrays can often be, for people who are new to coding, can be a little bit confusing or scary, but actually once you understand what they are, I promise you it's really not. So we're going to dive into it later, and don't worry, you will understand it. Okay. While we're talking about types, and you've seen me do it before, we can typecast. So I showed you the float and int. There's also str for string typecasting. So those are the different ways you can typecast. And I just want to talk about that for a second. So let's say we have our myvar and it's set to maybe 5. Well, let's just make it 5 like that. If I print it now, you'll see it prints 5, which is an integer. But I can convert this to a float. So inside of the print here, I can wrap the variable in a float typecast. And now when I print, it's going to make it 5.0. But it's important to note, after that, if I print myvar again, you'll see that it's going to print the float version and then the integer version, because when you typecast that, it is not changing myvar into a float. In the original, it's not overriding it. It is simply creating a float version that just gets printed, and then it doesn't overwrite the information. So when we print again without doing the typecast, it's printing the original, which is an integer. Okay. Likewise, if we did it over here and then printed it, just printed myvar, we would not get the float version of it, because of course it's just converting there, but that value is not being stored anywhere. We would have to actually store this in another variable and then print that variable, and then we would get the float version. Okay, so do keep in mind that it does not overwrite. Now, you can also do a string typecast, okay? So we can convert it from an integer to a string and then print that. It will look the same in here, but it does act differently. If you try to add numbers to a string, well, if you just try and add a normal number to that string, it's going to error because it can't take a string plus an integer. And if we made sure that that was a string as well, so either inside of quotes or inside of its own typecast, then it would allow us to add them. But when you add strings, it actually concatenates them. So 5 plus 5 actually is 55 because it's not treating them as numbers. It's treating them as two different characters. And so now you're adding them together. You're essentially appending to that array of different characters. Whereas if they were integers, of course, 5 plus 5 would be 10. Okay, so do keep that in mind. Also, something to be aware of, if we have, let's say we typecast our integer to a float, and then to a string, it's going to print with the 0.0, okay? So if, for example, this already had a float value, so it was a float and we wanted to print it, but we didn't want the 0.0, we would have to typecast it first as an integer and then as a string. Okay, so now we're getting the text, the character 5, not the number 5, and it has first been converted to an integer, therefore it drops the 0.0, all right? If you take a float that has a value like this and convert it to an integer, you will see it just simply drops the character. It doesn't do any rounding up or down. It just simply drops the floating point values and simply takes everything from this side of the period. So if you want to control the way it's rounded, you need to use actual rounding functions, not just rely on typecasting. Now, if we do want to convert from a string, so actually if I make this a string at first and then we want to convert to something like an integer or a float, then we need to be careful. In some cases, it's not going to work because it doesn't know how to actually convert that. So we would first need to actually make it a we would need to kind of manually go and drop the parts of it that don't that it can't convert to an integer. So we have to kind of help it get from string to int. So here we can go from the string to a float happily. So if we take that part away and go from string to float, it will now be a float nicely. And then we can wrap it in an integer and have it drop those characters fine. So now we've successfully gone from string to int, but we couldn't just do it without first going to a float, because basically it doesn't really know how to get from 5.8 to then figure out how to make that an integer, okay? Because it's looking at that period and saying, I don't actually know how to treat that. It's not first turning that all into one number and then going, oh, well, to go from float to integer, I just drop everything after the period. So you have to first help it get to float first, and then you can go to integer. Okay, so there's a lot of little tricks and gotchas around typecasting, but it's good to know. And the thing is, you will not always need to do this typecasting. Like I said, Python's pretty good at figuring out new typecasts. So depending on what you feed it, it'll just figure out the type most of the time. It's only when you come across these scenarios where you're trying to convert back and forward, or it's kind of getting it wrong, then you can force it to be a certain type. Next, it's important to note that you can do sort of basic maths within Python, right? So let's just go back to my var. We'll make it a 5, and then so what we can do is we can call a variable, and we can use, let's say, something like an add. So my var plus, and let's say we want to add 4 to it. Now, obviously, if we just do this and print, nothing's going to happen. It's going to just print the 5 because we haven't overwritten the variable. So we can say my var equals, and then we call the original value of my var, which is 5 plus 4, and it'll equal 9. We override that value, and there it is. Okay. Of course, you could, inside of the print, you could also add a value here. It'll print a higher value, but that value will also not be stored. So after the print, if you call my var, it would still only equal 9. All right. So keep that in mind. Now, you'll see here I did my var plus 4 equals my var, right? So we're sort of overriding the original with with the old value plus another number. A shorter way of writing this is plus equals. So you can just say plus equals 4. And that just says take the original, add this number to it, and then override it. So that's going to give us the same result. Okay. Now you can do addition, you can do subtraction, so minus equals 4, or just myvar minus 4, or whatever, it doesn't matter. Or you can say here 4 minus 2 if you want to, and it'll still all work. Okay. So these are ways of working with, addition and subtraction. There is also multiplication, so that's just the asterisk over there. So then 5 times 4 is 20, and you can do division. Now, when you divide, regardless of the values, it will always come out as a float. Even if, for example, it's 6 divided by 2, which would be 3, both are integers, and the result is a whole number. It is round, right? There are no values after the period. It's just 0.0. It will still come out as a float. So you do need to be careful of that. Of course, you can force it then to be an integer, but then you would have to actually turn it back into an integer. You could do that in multiple ways. You could just override myvar with a typecast, so myvar equals int myvar, and now we do drop it back down to an integer. Or you could say, instead of doing the divide equals, you make it all in one line. So myvar divided by 2, and then wrap the whole result in an int typecast, and that will still give you a 3 as an integer. All right. But just keep in mind, divide will automatically give you a float value. All right, so we've got plus, minus, times, divide. We also have brackets. So let's say we want to do something more complicated. So myvar divided by 2 plus 4, right? And now that's giving us 7. But because that's going myvar divided by 2, right, which is 3 plus 4. And it's doing that first because it's using BODMAS. I don't know if you guys did this at school, but we had this little acronym for, so it is brackets and then of, and then divide, multiply, addition, subtraction. And it does that in a descending order. So brackets are sort of more important and will be done first, then any of, and then division, then multiplication, addition, and then subtraction. So in this case, if we wrapped the 2 plus 4 in brackets, then it's going to be 6 divided by 6 rather than 6 divided by 2 and then plus 4. So we're going to get a different result. Okay, so I'm sure you're aware of that sort of maths, but just know that brackets do work correctly in here, and BODMAS does work. So things will go in the correct order. So let's say we said 3 plus as well here. So it's 3 plus myvar divided by 2. Now in this case, it's going myvar divided by 2, which is going to be 3, and then 3 plus 3. So it's not doing it in order from left to right. It is first prioritizing division, then addition, because of that ordering. Whereas if we wanted it to do the addition first, we could wrap this in brackets, and now it is 6 plus 3, which is 9 divided by 2. So then it's going to give us 4.5. Okay, so keep that in mind. All right, so that is everything for the very basics. In the next lesson, we're going to then talk in more detail about arrays.